Welcome to Spring LIB.
Okay, so we're going to answer the following questions, and in the first one we are reacting acetophenone. So a benzene ring with a 2-carbon chain, and on carbon 1 we have a ketone. So we're reacting with this. So the carbon adjacent to the carbonyl is known as the alpha carbon, and it has alpha hydrogens. So whenever you react it with a base, it's going to grab a hydrogen and eventually form an enol. The double bond's going to form there. This bond's going to break. So we're going to get this structure. We have the alkoxide ion, double bond right there, and reacting with this bond reforms. This becomes more reactive. So we now have an addition product. And if we repeat this twice with the rest of the alpha hydrogens right here, so let's say the base grabs both these hydrogens. So doing this twice, we'll eventually get to the structure. So this is R, by the way. We'll have Ci3, which is a better leaving group than the CH3. So again, reacting with base, it's going to attack the carbonyl carbon this time. Get the alkoxide, which is going to regenerate itself. Here's the addition of the OH. We still have the Ci3. And it's going to expel this group as opposed to the OH. So we'll get this structure. Plus CH, oh sorry, plus Ci3 minus. So it's going to deprotonate that group, and this is the product. So the alkoxide ion with CHI3. So this is B. This is the yellow solid. Say, I mean, this is structure 21. So for B, we have to show the mechanism for Br2 reacting with hydrogen or an acid to get the structure. So again, we're starting with acetophenone. So it's going to be similar to what we did in A, same mechanism, but this time it's under acidic conditions. So instead of the base deprotonating the methyl, the oxygen on the carbonyl group is going to grab a proton from an acid. If we use acetic acid, so ethanoic acid, it's going to deprotonate the acid, get the alkoxide ion. So this is going to be R again, this group. So it has a hydrogen, positive charge, and then we get this. The alkoxide ion. So this is going to deprotonate the alpha hydrogen, creating this bond. We get this. And then we have the with this structure. So it's going to reform this bond. And a double bond here too. So we get actually, let me do this. So once this bond reforms here, it's going to cause this double bond to attack a bromine, expelling that group, or breaking the bond right there. So we'll get the addition of bromine. The final step is for it to grab the hydrogen from the carbonyl. So we're going to get the same addition product, just a different mechanism. And for C, we're asked to convert 19 into 23. Again, starting with acetophenone. So we have this structure. So whenever you have this arrangement of a ketone next to an alkene, it's usually characteristic of an aldol reaction. So you have an enol reacting with either an aldehyde or a ketone. In this case, you have a ketone, which will become an enol. But so we have 2 carbons here and 3 over here. So if we reacted with formaldehyde, we only need 1 more carbon. But let's get the enol first. So this is going to become the enol. If we react with a strong base, like sodium methoxide, it's going to deprotonate the alpha hydrogens again. And then we get the same mechanism. So eventually the alkoxide ion, double bond there, this bond breaks. So this can be R again. We get this alkene right here. And then reacting with, so far we have 2 carbons, we need 1 more. So let's react it with formaldehyde. So it's 1 carbon. So this bond is going to break. This double bond is going to attack the carbonyl. So you get this, the ketone again, another carbon, and then we have the primary alcohol. So if we do, actually, hold on. Let me just redraw this. Do some hydrogens here. This is an alkoxide ion. They're reacting with water. It's going to deprotonate. We get the structure. So if we react it with either a base and heat or an acid and heat, it's going to give us the alpha beta unsaturated ketone. Whoops. So we get the alkene, and we still have hydrogens right here. So replacing R with the benzene ring, we get product. From the aldol reaction,